today, the title of today is going to be non-traditional integer strategies, models versus strategies. Today, I'm going to go ahead and show you how to add, I'm going to show you models and strategies of addition, subtraction, multiplication, and division. And I'm going to show you 2 different strategies and 2 different models for each. So I'm going to start with addition. It's the first number I'm thinking of, right? Not the first number, I'm so sorry. It's the first, first we're going to work with. So I'm going to go ahead and start with the numbers that I chose, which would be 99 plus 47. And all I'm doing is writing it like this. 99 plus 47. And the strategy that I'm going to use is called a give and take strategy. So this strategy is basically what it's saying. It's giving and taking. I'm writing down the strategy. So I'm going to go ahead and I look at the number, I look at the equation, and I think, well, I'm working with a lot of ugly 9s and I'm working with ugly 7s, right? We don't like those numbers. Or we don't like working with those numbers. So I'm thinking, okay, what is 99 really close to? It's really close to 100, right? You're just adding 1. So I'm going to go ahead and add 1 to 99. I'm just doing it like this. We're going to add 1 to 99. When I do that, it gets me 100. But to get the exact same answer and not getting a whole different equation, I'm going to have to take 1 from 47, which gives me 100 plus 46, right? So then I'm looking at it, I'm like, okay, well, this gives me a whole, many people think it gives you a different equation, but it actually really doesn't. It's the same number, you're still going to get the same answer, you're just giving and taking from 1. So it's basically like you're replacing it, if that makes sense. I'm gonna go ahead and, for example, for me, I work at HEB and I'm always shutting off cashiers. Well, in order for my lines not to get backed up in the back, I need to open up more lanes, right? But let's say I have one of my cashiers that need to go home. Well, instead of turning her off, I don't want to, because if I do that, then the lines will get backed up. So what I'm going to do is I'm going to take her off, but I'm also going to give 1 back. I'm going to give a cashier I'm going to go ahead and put a cashier on. So it's basically, I took 1, but I gave 1. So I'm basically replacing it. So when I do that, the lines don't get backed up. And that was that was a description for me to let y'all, for y'all to understand. So this is the exact same thing. I am giving and taking. I gave 199, but I took it from 47, and it's replacing it. It's not a whole different thing. It's not like I turned off 2 registers. I replaced it. And the way we did here in the problem, it's for us to get a friendly number that we like working with, a more efficient number that it's easier to work with. So when you look at 100 plus 46, you're like, okay, well, that's easy. That's 146, right? And that's your answer, so that's correct. And the model that we're going to go ahead and do today is a number line model. I'm going to go ahead and draw a number line. So I just drew a number line model. A number line, right? Like a number line that you always see. I'm going to start off with 99, since that is the number we're starting with. And I went ahead and put 146, because now we know our answer. That's what we're trying to get to. So I'm going to do exactly what I did on top. 99 plus, I'm going to add 1, gives me 100. Then I'm going to go ahead and add 46 to it to get me 146. I didn't, show how basically this is what I did. 99 plus 1 to 100, and 100 plus 46 would be 146. I didn't show you how, I didn't put in the number line 147 minus 1. You can do that, that's your preference, but for me, I found it more efficient this way. I just basically summed it up in a bigger area. That is a number line model. So the strategy I just used was a give and take, and a model was a number line model. I have not told you what a strategy and model is, so let me go ahead and tell you that right now. I'm so sorry, and I'm going to be completely honest, I did this video 3 times now. Either someone calls me and my video stops and it's bothering me. So a strategy is how you use your numbers. It is how you use relationships and connections between the numbers to solve a problem. A model is a representation of your strategy, the way the strategy looks visibly. So basically, a strategy is a connection between the equation and the numbers you're using. It's a connection between the way you solved your problem. And a model is basically it's a reputation of what you did. That's all we're doing. How the number line is just a reputation of what we did here. And I did a give and take strategy, and I'm the model I'm using is the number line model. So now I had showed y'all your two strategies. Oh no, I have not showed you your two strategies. The next strategy I'm going to go ahead and do is I'm going to use a different strategy in a different model. So we're going to go ahead and use the same equation, 99 plus 47. And this one I like. It's called a place value splitting. No, it's called a place value splitting strategy. And the reason why I like this is because we're basically breaking it apart. So when I look at 99 plus 47, I'm going to break it apart. I want to make it to where it's easier and more efficient for me to work with it. So what I'm going to do is I'm going to break 99 apart. 90 plus 9 gives me 99. And 40 plus 7 gives me 47. I'm going to show you how I did that. So I just broke it apart. All I did. Now I can work with 90 and 40, and that will give me those are two numbers that are easy and more efficient for me to add. That will give me 130. And then I did 9 plus 7, which gives me 16. And that's all I'm doing. I am breaking it apart for me to work with more efficient numbers and to add efficient numbers that I like working with and still giving me the exact same answer. So what's 130 plus 16 is 146. That is what we did. This is called a place value splitting strategy. And the model that we are going to go ahead and do is basically, it's called an equation model, and it's basically how we normally do addition. So I'm going to explain what we did. We did 90 plus 40, 130, and we did 9 plus 7, 16 gives me 146. And that is basically what we just did. 90 plus 40, 130, 9 plus 7, 16. Add those together, give me 46. 146. I didn't even write the 6 on that up. That is called an equation model. That is a way that we like using it. So with that, I did show you there's two strategies and two different models with the exact same equation. I really like using the place value splitting strategy. It's basically splitting apart the numbers and for me to be in a more efficient numbers to use and add. Next, we're going to go ahead and do subtraction. The numbers I'm going to go ahead and use is 41 and 18. I'm going to go ahead and start with the number line. And I am going to go ahead and start with 18. And I'm going to put 41 in the end because that is where we're trying to get to. So I'm going to do is, what is a close number? 18. I look at it and I'm trying to get to a number that I like working with, a number that is more efficient for me to work with. So I'm like, well, 18 is fairly close to 20. So I'm going to actually add 2 to give me 20. Right? A number I like working with. From 20 to 41, I look at it. How do I get from 20 to 41? I add 21. But then I look at it, and I'm looking at this, and I'm thinking, okay, the way I'm going to get my answer and the way I'm going to find out what is 18 subtract by 41 is when I did this problem, this model, it gives me the answer on the top. So I did 2 plus 21 gives me 23. And if you look at it, 41 minus 18 is 23. That strategy is called 2 meanings for subtraction strategy. And the model that we just did is a number line model. And that's honestly a really easy way to do subtraction. You put your two numbers, the number you're working with, the number in the end, and you make the first number you want to be more efficient, and then you get that number to 41, or for the number that you're subtracting with, and then on the top gives you your answer. Now we're going to do another strategy. 41 minus 18. We're going to work with the same one. And I'm going to do the exact same thing I did on the top with the first strategy. I want to make 18 with a more efficient number I like working with. And that, I'm going to add 2. Will get me 20. But if I add 2 to 18, I'm going to have to add 2 to 41. Something similar to like the give and take, but it's not. This is actually a strategy called the constant difference strategy. Constant difference strategy. I am getting a number to an efficient number I like working with, but if whatever I add to it, I'm gonna have to add to the other one. That way I don't get a different equation. That way I don't get a different answer. So it can be the exact, so I can get the exact same answer. It's like how we did the 91 plus 1, but we have to subtract 1. But this is you're adding 2 and you're adding again. So that way you're gonna get a number, but you're gonna get an efficient number. So that way when you subtract it, it's a more easier way of subtraction. So now you look at it, and it's now it's an easier number to subtract. It's 43 minus 20. Well, what's 3 minus 0? 3. And what's 4 minus 2? 23. And that is your answer. That's how I did it. I did 41 plus 2, 18 plus 2 to give me 20. And I did 41 plus 2 because you have to get the exact same answer. And if you just did 41 minus 20, you're not going to get the answer. You're not going to get the efficient answer you need. Or the correct answer. So you would add 2, that way it's like a replacement. So that way you're not going to get a different one. So I did 43 minus 20. I did that so I can get a number to subtract an easier number and a more efficient number that I like using. That way it can give me 23, the answer. And that model is just called an equation model. So those were my 2 strategies and my 2 models that I did for subtraction. Now we're going to go ahead and go for multiplication. In multiplication, it's getting a little more difficult, not as difficult, but it's every step's a little bit. So 20 times 13. I look at this, 2 big numbers, 20, 13. 20 is a nice number, but you're timesing by 13, and 13 is not a nice number. So this is where it's like, oof. What I do, and I look at it, and I think about it, but I go, okay, what is 20 times 13? Well, first, what's even 13 times 4? Because 13 is a very difficult number to multiply. When you're starting out, it's like, okay, well, that's a big number, So I'm going to go ahead and find the multiples of 13. I think that's what I'm going to do. And I am going to do this actual model that I'm doing. It's called a ratio model. It's a ratio table model, I'm sorry. And all I'm doing is just doing 1 times 13 gives me 13. And now I'm going to do 2 times 13 gives me 26. And then 3 times 13 gives me 39. But if I look at it, those are basically multiples of 13. That's all I was doing. I was trying to find, but instead of doing 1 times 13 is 13, 2 times 13 is so-and-so, 3 times 13 is so-and-so, 4 times 13 is so-and-so, 5 times 13 is so-and-so. Instead of doing that, it's going to take a long time. But that's basically what we're doing. We're just finding the multiples of 13. So it's like 5, 10, 15, 20. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. Instead of doing that to get to your, 5 times 6 or whatever, you're basically finding the multiples of 13. But I did it, instead of doing that way, the way of the long way, where you have to go 1 all the way to 20, I try to find things in the equation similar. So if I look at it, I think, okay, well, 20 and 2, what do they have in common? Well, 20 times 10 2 times 10 is 20, right? So I'm going to go ahead and times by 10 to give me 20, because we're trying to find what 13 times 20 is, or 20 times 13 is. So if I was already doing the multiples of 13, I just jumped from 2 to 20. And that saves me space of going all the way to 20. Because we could do that. You can totally do that, but there's more an efficient way. And this strategy that we're using is times 10 strategy. So what I did is I did 2 times 10 to give me 20, because you're trying to find what 20 times 13 is. So now I'm thinking 20 times 13 is, but if you look, you have 2 times 13 is 26. So if you times 26 by 10 to give me the answer of what 20 times 13 is, you get 260, and that is the correct answer. And like I said, that strategy is called times 10 strategy. I times 10 to find my answer. Now we're going to do the same equation, 20 times 13. We're going to do a different strategy and a different model. So when I look at it, I look how like the place value splitting one, how we break it apart. I'm going to break 20 and 13 apart. Okay, and I'm going to draw a square, and I'm going to put a t inside of it. So it gives me 4 squares, just like this. And on this part, I'm going to put an X. That way, it's part of how I learn. So I'm going to break 20 apart. 2 numbers to give me 20 will be 10 plus 10. And I'm just going to fill it in right here. I break it apart, 10, 10. What are 2 numbers to give me 13? 10 and 3, right? 10 plus 3 is 13. So now, when I see this time, it's like a multiplication chart. So now I see 10 by 10. You know how when you had the multiplication chart and you had 3 and you'll go down to 5 and you meet to get your answer? This is basically what this is. But right now we're filling it in. So you're looking at 100, 10 times 10 is, and I just said the answer, 100. And then you do it again, 10 times 10 is 100. And now you're doing 3 times 10 is 30, and 3 times 10 is 30, right? So now I'm going to add all those up. So 100 plus 100 is 200, plus 30 plus 30 gives me 60. So 200 plus 60 is 260. I just broke it apart. I did 100 plus 100, up and down. 30 plus 30, you add those together, you get 260. That strategy right there that we just did is called a distributive property strategy. Because I am distributing. I cannot say that word correctly. I'm breaking it apart. And the model that we just did is called an area model. So now we're going to go ahead and work. I just did my 2 models and my 2 strategies that I did with 20 times 13. Now we're going to go ahead and go to division. Division is very fun. We all like division. So I'm going to work with 198 divided by 9, right? Whoa. Everyone looks at that and you're like, what the heck? So with this, 198 divided by 9, I'm going to go ahead and try to work with numbers that I'm used to. And I'm thinking, okay, well, 198, what is another number that 9 can be divided by? And I'm thinking, what is 198 close by? And the first thing I thought of was 180. Because I know that 9 divided by 18, no. Yes, 9 divided by 18 is 2. So if I do 9 divided by 180, which is close to 198, gives me 20. So then I'm thinking, okay, well then if, I look at it, I'm not even showing up. I just wrote it right here. And I know that 9 divided by 18 is 2. And if 9 divided by 18 is 2, then 9 divided by 180 is 20. Ooh, 20. So now I'm looking at it, and I'm like, okay, well, that is not that hard. I mean, those are 2 numbers that I can work with. But then you're thinking, well, how does that even work? How is this gonna help me find what 198 is? So I'm thinking, and I'm looking, and I'm like, well, if you add 180 with 18, it gives me 198, right? So I'm like, oh wow, that actually makes sense. Oh, I'm so sorry. Sorry about that malfunction. So you're like, oh wow, that's cool. So I just did 180 plus 18 gives me 198. So if you do 20 plus 2 gives you 22. So then 9 divided by 198 equals 22. But that is basically like how we found it out. Now we're gonna have to do it with the model. So that strategy that we just did is called a practical quotient strategy. I'm gonna go ahead and write that out. And now we're gonna go ahead and do the model. So the model that I'm going to go ahead and use for division, I'm going to actually go use the area model. I'm going to do what we did with multiplication. I'm going to do the little, but in this case, I'm not going to do the little 4 squares. I am going to just do it in half. Just like division. You know how you have the little division bar? Like this. You're dividing, that's what I'm going to do. So what I'm going to do is, okay, I'm going to write 180 inside and 18 inside. So now, it's as if I'm doing 180. A number divided by a number gives me 180, and a number divided by a number gives me 18. It's like doing this, but in a bigger area, in a bigger model. So I'm thinking, okay, well, I know 9. I know I'm going to be divided by 9. And I just said, well, 9 divided by, 9, I just said 9 divided by 180 is 20. So then I know 9 times 20 gives me 180. And if you know 9, let's not show you. Ooh, I just hit my head. Like this. 9 times 20 gives me 180 because we just did this here. Then I know 9 times 2 gives me 18. Then all I have to do is add 180 with 18, which gives me 198, and add the top, and this gives me 22. So that gives me 22 as my answer. So basically, this is what I did. Exactly what I did here, I did it here. I did 9 divided by 20 to give me 180, 9 divided by 2 to give me 18, and add these two up to give me 198, and you add 20 plus 2 gives me 22. That's what you get when you get, that's how you find out the answer, what 198 divided by 9 is. It was 22, it's 22. So all we did there, and people are probably like, what the heck? All we did was try to find numbers that were that are closest to it, or, similar to it. So like 198 divided by 9, you're like, what? But if you do 180, that's close to 198. But then you also can be like, well, 180 can also be 2. So you're trying to find similar, problems like that help you out. So I just basically did, okay, well, I know 9 divided by 18. I go from the bottom. 9 times 2 equals 18, right? But if I'm trying to find what 9 divided by 180, which is like 18, then I know it's going to be 20 times 9 gives me 180. And I add those two up, and I get 198. So I will just add these two up. And that strategy is called a partial quotient strategy. And the model that I just used was an area model. And the last strategy and model that we're going to use is I'm going to go ahead and use a rational table model. Okay? And we're going to use this again, 198 divided by 9, right? Well, for me, I'm going to go ahead and do like what we did when we're trying to find the multiples. If I don't know, like we did with the multiplication, I'm going to find multiples of 9. That way I can see what 9 times what gives me 198. So 1 times 9 is 9, 2 times 9 is 27, 3 times 9 is 36, and let's do 4 times 9 is 54. Right? I just went up to 4. And I'm going to look at it, the table. That's all I did. I'm just finding multiples. Because I'm going to try to find the multiple. 9 times what gives me 198. So 1 times 9 is 9, 2 times 9 is 27, 3 times 9 is 36, and so on and so on. But I look at it, and I'm like, okay. Well, what I'm going to do here is how we did there. 20, because you know how you did the top, the arrow, you got 20, because you know what 20 is. No, I'm sorry. 2 times 9 is not, no, 27, it is 18. I'm so sorry. Yeah, so you go, okay, well, 2 times 9 is 18. So then I'm going to go ahead and times by 10 to give me some 20. And that would give me 180. Well, then I'm just going to go ahead and add, because 180 plus 18 is 198. And what is 2 plus 20 gives me 22. I kind of wrote it all ugly, so don't mind it. This is a ratio table model. I did the factors of 9 to help me find what 198 is. Well, when I did 2, I'm going to go ahead and times that by 10, like what we did up here, to help me out. So I times 2 to give me 20, and I times by 10, and I times 18 by 10 to give me 180, and I added those 2 up to give me 198. So then I just added what 2 and 20 were, and what was be 22. The strategy that I did here was an over and under strategy. And the reason why I did an over and under, why I call it over and under, it's because I went over. I went way over. I decided to just go over the moon, and I went under. I say under by like adding it smaller, but I went over. The way I call it over and under is because I went over by 20 times 10. I would call it times 10, but I don't want it. It can be 2 same strategies, but I would also call this one an over and under strategy because I went over the number. So that's what I would say. I called it an over and under strategy, and the model I did was a rational table model. So those were the 2 models and the 2 strategies I did for division. So I overall did 2 models and 2 different models and 2 different strategies for addition, subtraction, multiplication, and division. I did 4 different. I did 4 basic operations, and I did 2 for each of those. I did 2 different strategies to solve my problem, and I worked 2 different models for each. That is it for today, and that was for the non-traditional integer strategies, models versus strategies. Thank you.